This is section 3.10, related rates. This section is all about word problems, and I think what's really hard about word problems is that each problem seems really different from the last one. But as we go through this example, we're going to go through a step-by-step guide of how to approach this problem, and hopefully by the end of this video, you have a better idea of how to start these problems and a better process of how to go through them. So let's go through this example. This is really similar to number 13 in your book, and it tells us that a conical tank has a height 5 meters and radius 2 meters at the top. Water flows in at a rate of 2 meters cubed per minute. How fast is the water level rising when it is 2 meters? Okay, first step in our process is draw a picture, the best step. So they tell me it's a conical tank, so here's my cone, and they tell me that it has a height of 5 and a radius of 2 at the top. Okay, so I just drew all that out. They also tell me that water flows in at a rate of 2 meters cubed per minute. That's going to come in later. I'm not going to draw that on my picture. And then they are asking for how fast is the water level rising when it is 2 meters. Okay, so imagine there's water flowing into this tank. They're interested in the water level down here at the bottom of the cone. So I know it's going to have to do, this problem is going to have to deal with some smaller cone down here at the bottom. So I'm going to go ahead and label that out. My small cone here has a radius of x, and I'm going to say it has a height of y. Okay, label my picture. Step 2, write down all my givens. This is pretty similar to step 1. I know some of the givens is that my height is at 5, my radius is at 2, and they also tell me that water flows in at a rate of 2 meters cubed per minute. Okay, so they're telling me it's at a rate of 2 meters cubed per minute. Whenever you see this word rate, you want to think derivative, because remember, the derivative is just the rate of change at a specific point. And look at these units. They're giving me meters cubed per minute. Remember, cubic units, that's referring to volume. So they're telling me that as water is flowing into this cone, the volume is increasing at a rate of 2 meters cubed per minute. So I'm going to represent that as dV over dt, the change in volume with respect to time, is equal to 2 meters cubed per minute. Okay, wrote down my givens. Step 3, write down what they're actually looking for. If you go to the last sentence in this question, it's asking how fast is the water level rising when it is at 2 meters. All right, the word fast, that should also make you think of derivative. They're asking for some derivative. What derivative are they asking for? They're asking for the water level rising. So in other words, how fast is this height increasing? How fast is y increasing? So we're going to write that as dy over dt, the change in y with respect to time. That's what they're looking for when it is 2 meters. So when y is equal to 2. So when y equals 2, what's the rate of change at that moment? All right, so steps 1 through 3, we just wrote down our givens, wrote it in a picture, wrote it in mathematical terms. Step 4, we're going to put all this information together and come up with an equation that relates what we're given and what we're asking for. So they gave us a unit for volume, so we know we're going to use our volume equation. If you remember, the volume of a cone can be found by 1/3 pi height times radius squared. But in this case, remember, they're interested in this little cone down here. So we're going to say that our height is y and our radius squared is just x squared. All right, so we have an equation, but remember what they're looking for is dy over dt. In order to get from this equation to something that has dy over dt, I would need to take the derivative of this equation and then end up with dy dt over here. But if I were to take the derivative of this equation as it's written now, I have too many variables here. I wouldn't be able to solve it. So what I need to do before I take the derivative is rewrite this in terms of just 2 variables. Okay, so at this point we need to come up with another equation. Pro tip, a lot of these problems have to deal with triangles. Either you're going to use Pythagorean theorem or you're going to have similar triangles and set up a ratio. This is one of those problems with similar triangles. We're going to use our big cone and our little cone relationship to have a relationship between y and x, solve for one of the variables, and plug it back into here so that this equation is written in terms of only 2 variables. So let's go ahead and set up our proportion. So if you remember, proportions of similar triangles, I can put the height of one triangle over the radius of the other. In this case, my big triangle is 5 as the height, radius is 2, over the height and radius of my other triangle. So my height in the little triangle is y, the radius in the little triangle is x. And from here, to solve for my variables, I'm just going to cross multiply. And when I do that, I get 5x is equal to 2y. Okay, when I'm deciding which variable to solve for, remember what they're asking for is dy over dt. So that means I still need to have y's in this equation when I take the derivative. So I'm going to solve for x in terms of y and then plug it into here. When I solve for x, I get x is equal to 2/5 y. All right, have this value for x, plug it in here. When I plug it into my volume equation, I get volume is equal to 1/3 pi y times, I'm going to go ahead and distribute the square. 2 squared is 4, y squared over 25. Let's multiply this out just to simplify it a little. I get 4 pi over 75, y times y squared gives me y cubed. Okay, now I have an equation that's written in terms of only two variables. I'm able to take the derivative of this function, and I would be able to solve for dy dt pretty easily. Because remember, that's my game plan. I want to get dy dt and be able to solve for it. So I have this function, and I'm going to take the derivative of the entire thing and see what I get. So on the left-hand side, I get dv over dt. On the right-hand side, I'm going to treat this entire part, the 4 pi over 75, just as a constant. It's just a coefficient. So I just leave 4 pi over 75 here. To take the derivative of y cubed, I use a power rule, bring 3 to the front, subtract 1, get 3y squared. And for these types of problems, you're also going to write dy over dt here, kind of like implicit differentiation. Okay, so here's the function that I have when I took the derivative. Remember, solving for dy dt, as it's written now, it looks like I still have too many unknowns, but remember what they told me. They gave me dv over dt, and they also told me what y value they're interested in. So I'm just going to plug those values in. The dv dt they told me was 2 meters cubed per minute equals 4 pi over 75 times 3. The y they gave me was 2. 2 squared gives me 4. Dy over dt. Okay, from here, now I can just solve for dy dt like I normally would. Multiply all this out, divide it over to the left side, and when you do all that, you should get that dy over dt is equal to 0.99 meters per minute. Remember my units here. It's just a measurement of height, so my units are just meters per minute. And that's it for this problem. So brief recap. For the first 3 steps, I just wrote down what they gave me and what I was looking for, just so that I had the entire problem so that I could understand it better. Then step 4, I had an equation that related all the things that they gave me and the things I was looking for. But remember, before I could take the derivative of this function to get what I was looking for, I had too many variables. So I had to come up with a relationship between my variables so that I could solve for one, plug it back into my equation, and then take the derivative from there. And then after that, it was just solving for what they were looking for, which was dy over dt. I'll have a couple other videos going through other examples in this chapter, or in this section, but this step-by-step process can really be used for any problem in this section. So I hope this was helpful. I hope you found this video really helpful. The concepts covered in this video are true no matter what calculus class you're in, but all the sections and problems I referenced were from this textbook right here. And remember that if you're a registered Baylor student, we offer free tutoring on the first floor of Sid Rich. You can either schedule a one-on-one appointment online or just drop in whenever you're available during our business hours for free tutoring. For more information, feel free to visit our website.